Good morning, class. My name is Miss Sarah, and today we'll be going over some radiology topics that affect X-ray images. We're going to be speaking about 8 different topics. First one will be contrast. Second will be density. The third one will be distortion and magnification. Fourth one will be recorded detail. The fifth one will be source to image distance, which the abbreviation for that is SID. The sixth will be film screens. The seventh is filtration. And last but not least will be grids. Do you ever go to a radiology department and wonder, oh my God, how are they going to take this x-ray of my bones? Sometimes you may fall or get in an accident, and you may have some pain on your hand or your foot or a different body part, or you may be playing a sport at school. Well, doctor will order an x-ray, and what the x-ray does is image the body part that is injured. And it'll show the bone, sometimes it shows other tissues. So really interesting. In order to get this image on a piece of film, there's many topics which we're going to go over today that involve in getting this image on the film. And looking at the image and looking at the colors, the density, and the factors that we use in the x-ray room to get these qualities. So the first lesson will be high and low contrast. You're probably wondering what contrast is. Well, the contrast is the differences between black and white, which are the two colors. For example, here I have a white poster board, and here I have a black poster board. So when looking at a radiographic image, you're looking at white and black. Now the grayness is the white and black mixed together, and that is what contrast is. The contrast, the technologists will control that, and that's controlled by the kilovoltage, which means the power, and that also can be known as kVp. There's 2 different scales of contrast. The first scale is short scale and high contrast, and the second is long scale, low contrast. When you adjust to kVp, which is the kilovoltage, the amount of power that the x-ray tube is going to release, you're changing the contrast. So if you give that x-ray tube a lot of power, that contrast, the black and white, is going to be very, very low. Other things that affect the black and white, which is the contrast, is SID. When we started this lecture earlier, SID stands for source to image distance. And that, for example, is, let's say this is my hand and the x-ray tube is up here. The distance between the x-ray tube and the source is this to here. Contrast does affect the image by making it look either gray, which is the low contrast, or black and white, which is the high contrast. And most of the time we do like the black and white contrast. You get to see the bones better. It depends on what body part you're getting x-rayed. Another thing that affects the black and white on an x-ray is filtration. What that is sometimes, for example, if you're getting your foot x-rayed, your bones in your toes are really tiny compared to the rest of the bones in your feet. So what the technologists will do is put a little filtration device, which I'll show you later in this video, in the lab, where it will be placed on top of your toes so that the energy of the X-ray beam as it's passing through your body part, it's the filter, what the filter is doing is minusing or taking away those low energy, so you can actually see the bones in your toes and also the rest of your bones in your foot and like an even black and white. You can clearly see all bones. Now if you didn't use the filter on top of your toes, what will happen is that energy that's coming from the X-ray tube will be so strong that your toe bones are so tiny that you won't be able to view those bones on the X-ray when it comes out of the processor. So you will only be able to see the foot bones, not the toe bones, because they will be like burnt out. They will be completely black on the X-ray image. The next topic we're going to talk about is density. And density equals visibility. That's a very important key to radiography. What density is the overall blackness on an image. How much blackness is on an image? For example, if you think about it, if there was an image that was darker than another image, like let's say you have one lighter image and one darker image, which image would show you better detail? It would be probably the lighter image, because a darker image you may not be able to see, for example, as I stated earlier, the toe X-ray. You wouldn't be able to see the little bones that are also in your body besides the bigger bones. And what controls this density is something called a milliamperage second, and that also is known as mass. It's MAS. If you use enough mass, you will be able to see all the little detail in your bones on the radiograph. For example, if you were going for a chest X-ray in the radiology department, if they use enough mass, equal mass in kVp, they'd be able to see your spine and also your heart, besides all the other chest, like your lungs and your ribs. So you'll be able to see a lot of body parts on your chest, okay? And for example, if you go in for an abdominal X-ray, you'll be able to see the muscles also on the radiograph if the right density is chosen by the technologist. Now, if there's not enough density, your X-ray is going to be really light. And if it's too much density, as I said earlier, it will be very dark. It will be a very dark image. Other factors that can affect density is also the SID, which I stated earlier was the source to image distance. That also affects the contrast. Another one will be the filtration, like the filter device that would be used on top of your toes. That would affect the density also. And also a grid. What a grid is, it's a rectangle shaped device that you put the cassette in. And I'll show you later in this video how you would put the cassette into this grid. And what the grid does is help with the density. It makes it look prettier. Next topic we're going to talk about today is magnification and distortion. So this title will be magnifying and distorting. You're probably wondering, what does magnification mean? Well, magnification is like magnifying, making something bigger on a picture. For example, like using a magnifying glass, maybe during science class, or other projects that you may be involved in. if you put a magnifying glass against your nail or your finger, it does get bigger as you move it further away. And that's the same concept that we use in X-ray. And distortion is a body part being X-rayed, and then when you view the X-ray, it looks different in shape than what it's really supposed to look like, or different in size. It may look bigger or smaller, or it may look, if it's supposed to be round, it's probably a rectangle shape. Or it may even make your arm look shorter or longer. If you ever get an image and that's what you get is the magnification distortion, what you have to do is go back, and the technologist, what he or she will do is either make that source to image distance a lot bigger, or if my cassette is right here and my hand is right on top, he or she may have to lift your hand up just a little bit, so there is some distance between your hand and that cassette, and that will also fix density. That will also fix the magnification or the distortion. What causes the distortion, the magnification, making it bigger, is the distance between the X-ray tube and the source is probably really low, or this distance between your body part and the cassette that's underneath it may be too high, or the cassette is probably just not lined up with the body part that the technologist is trying to X-ray. The next topic we're going to talk about is reported detail. The title will be "The Sharper, the Better." You're probably wondering what reported detail is on film. Reported detail is the image sharpness, how well you can see the outlines of your bones and the markings in your bones. So you can see the difference between the bone and the tissue that is surrounding that. And I would consider your tissue as like your skin. If you have a high distance between your X-ray tube and the source, the detail will be a lot better. Now, if the distance between your body part and that cassette is really high, the detail is going to be really low. So in order to get better detail, the body part that we're getting X-rayed, whether it be your chest, your feet, or your hand, has to be really close to that cassette in order to get the best picture possible. Sometimes when getting X-rayed, you may move, or of course you need to breathe, but that little bit of movement can sometimes change that detail and make it low. For example, or even the equipment might move for some reason, and that will make the detail really low, which is not good. Other names that are used for reported detail is resolution, sharpness, or just detail. Those are other names that you might find in other books, or when other people talk about reported detail, they may use those words to describe it. And later in the lab, I will actually show you a hand X-ray, both hand X-rays actually, that show really good detail and all the markings in your bones of your hand. The next topic we're going to talk about is source to image distance, and distance is a key. Source to image distance, also, as I said earlier, is called SID, is the distance between the tube and the cassette. So you're probably wondering what does SID affect? It affects contrast, which is the black and white, the density, which is the overall blackening of the film, and also the recorded detail that we just talked about. If the source to image distance is really low, the density is going to be really high. So you're going to see a lot of black on the radiograph if your source to image distance is really low. Now for recorded detail, that would be really high if the source to image distance is also high. So you want to have a lot of room between that source, the X-ray tube, and the image to get a really good recorded detail, so you can see those markings in the bones. And the person that will actually change the SID is a technologist, and later in the lab I will show you how the SID can be measured with a measuring tape. And actually I have a little measuring tape that you will probably find at home, maybe your mom or your dad would use around the house. But there is a measuring tape like this attached to the X-ray tube that you can just pull down actually this way and measure. And that's how the technologist knows how far away he or she is from the cassette. The next topic we're going to talk about is film screens. And this is kind of like a combination of film and screens. There's 3 different speed screens. For example, the first one is the 100, and that's the detailed one. That's the one that will be used on your foot or your toes or your finger or your hand. And that shows the best detail. The one in the middle is called the 200 speed screen. And that's a little bit slower than the 100. It's not that fast though, it's kind of in between. And it shows less detail than 100. And the last speed screen is called the 400, and that's really, really fast. But since it's really fast, it has very, very little detail. So we have to make sure if we're x-raying a small body part, or your finger, or your hand, or your foot, or your toe, or even your knee, we want to probably use the 100 screen speed. So the lower the number, the better on the screen speed for detail. We also have to make sure that the film and the screen match. That is a big key to radiology. For example, if we have a green screen, we will also need a green film. But if there's a green screen and there may be a blue film, what's going to happen to the image is it's going to be very, very blurry, and that you will not be able to see your bones clearly on the X-ray. But if they match, if we have the blue screen and the blue film, then you would be able to see the detail. Also, let's say the blue film and the green screen, they don't match, well, what can also happen is there'll be a high patient radiation dose, and that is not good. And in the lab, I will actually show you the different cassettes, the 100 to 200 and the 400 speed. The next topic we're going to talk about is the filtration. We talked a little bit about it earlier with the contrast and density. Okay, well, the filtration, like I said earlier, is getting rid of those low energy. And usually the filters are usually probably made out of aluminum. That will help. That's what they're made of. And the technologist, as I stated earlier, uses the filter and places it on top of the body part. For example, one example of the filter is a wedge filter, and that's placed on top of the foot, as I stated earlier, so you will be able to see the bones in your toes. There's another filter called a double filter, and that's for bigger body parts, for example, your chest, or if we're doing your back x-ray. And that will also be placed on top of the body part being x-rayed. The only bad thing about filtration is it causes a high patient dose, just as the wrong film and screen combination. For example, if we had the blue film and we had a green screen, that is not good. We do not want high patient dose. We want very low patient dose. Now we'll actually show you the wedge in the lab later on in this video. Last but not least, we have grids. And I explained to you earlier that the grid is that rectangle shaped device that we put the cassette in. Well, there's also a grid holder that I'll show you later in the lab. And what that does is hold the grid in the cassette so it doesn't move once you get the patient positioned. Grids are used in radiology to make the contrast better. And the way they do that is they remove scatter. And scatter comes from the beam. As it's coming out of the x-ray tube, it's going this way. And the beam scatters away this way, and the ones that go this way is the scatter. But what the grid does is prevent that scatter, and it improves the contrast. So we don't want scatter because that messes up the picture. And scatter is bad stuff. It does not give you recorded detail, as we spoke earlier. You want to be able to see your bones and the markings in your bones, and whether you have a broken bone or not. That's the only way you'll be able to view that. Technologists may even use a grid if the kilovoltage, as I stated earlier, the power, if she uses more than 60 kVp, she will need a grid. And also, let's say you're going in for a knee x-ray. They will measure your knee right in the middle of your knee. They would measure it using a caliper. And if that measurement is more than 10 centimeters, he or she would have to use a grid with that cassette. When the grid is used, the contrast is high, so you have more black and white when that grid is used. And I will show you in the lab on how to put that cassette in a grid, and also the grid holder and what purpose that has to it.